Hi guys, it's Cheyenne here. Longtime subscribers may recall that over the summer I had the opportunity to work with Probably Genetic. Probably Genetic is a company that offers accessible, affordable, clinical grade whole exome sequencing for patients. If you have a chronic illness and you've ever looked into genetic testing, you'll know that whole exome sequencing is very pricey, especially when your insurance does not want to pay for it. Well, Probably Genetic asked me to reach out to my community to share with you all information about the program they just launched. It is a sponsored program for mitochondrial disease, and patients who are eligible based on the intake survey, they will potentially receive a free at-home testing kit from Probably Genetic. This means that they won't have to pay the out-of-pocket cost for the testing at their geneticist's office, nor will they have to pay out-of-pocket costs for Probably Genetic. They will get whole exome sequencing entirely free, which is a great deal. Mitochondrial disease is associated with many of the comorbidities that I have. For example, dysautonomia, POTS, gastroparesis, chronic intestinal obstruction, and more. And I am very passionate about genetic testing because the sooner you can find the underlying cause for your symptoms, the sooner you can implement treatment and get to feeling better. A couple days ago, I had an interview with Lukas, who is the co-founder of Probably Genetic, and I decided to set up this interview style video to share with you all of the information directly from the source. While I can share with you my patient experience all day long, I think that a huge aspect of deciding whether or not to pursue genetic testing should come from a professional. So I'm going to get right into those questions. What is Probably Genetic?
My name is Lukas. I'm the CEO and co-founder of Probably Genetic. Probably Genetic is a rare disease startup. Our mission is to diagnose 200 million people with rare genetic diseases. And the way we do this is we operate a service where we try to find people that have likely undiagnosed rare genetic diseases, primarily online. And then we operate a clinical at-home testing service where we ship people a test kit, they spit into it, ship it back to our lab, and a few weeks later, they get a result via a genetic construct session.
What inspired you to begin the company?
I did my PhD in genetics and specifically in rare genetic diseases at the University of Oxford. And I worked on on a really big whole genome sequencing study. And the purpose of my PhD was figuring out for undiagnosed rare genetic disease patients, once we got their genetic data in, what's causing their disease. And as I was doing this, I got to meet a lot of patients and patient families. And the overarching reality, no matter what disease the family was affected by, was every single one of those patients had been really ill for years before they found out what their diagnosis was. That's sort of where the motivation came from, to try to figure out scalable ways using technology to help patients with undiagnosed severe diseases find out earlier what they have. For people in the rare disease or a SPOONY community, we're trying to shorten the diagnostic odyssey. And also, there are so many terrible things that happen while you're undiagnosed, right? Like you get misdiagnosed a whole lot. Treatments might be prescribed based on misdiagnoses that you shouldn't actually be getting. Medical bills are insanely high. You need to see tons of specialists. There's one statistic I saw that says 40% of families affected by rare diseases go into personal debt while they're on the diagnostic odyssey. Our philosophy is if we could just find people earlier and help them find out what they have much earlier in the process, we could not only help them get the right treatment faster, we could also potentially help them avoid a whole lot of these other things that happen while you're undiagnosed.
What do you find to be the most rewarding aspect of your role at Probably Genetic?
I honestly like moments like this. Like I really, I really enjoy talking to you. I really enjoy engaging with all the people that use our service because it's incredibly rewarding to see that it makes a difference in people's lives. You know, we started the company in 2018, so it's been quite a journey since, and there's a lot of hard work involved, and everybody on the team is really talented, and they could have chosen to do other careers, but instead they decided to follow this bigger goal of actually trying to make a change in people's lives happen. And so whenever I can engage with the patient community, I think that's I'd say that's probably the most rewarding piece of it. And then another thing that I enjoy is like I'm a engineer and scientist by training, which means like by all standards I'm a total nerd, and the stuff we do is really hard. And I enjoy the opportunity to work on important, difficult problems, and this is an important, difficult problem.
Many viewers may not know what whole exome sequencing is. What is it? Tell us a little about the process.
So whole exome sequencing is a lot of different things. I think it's for one, like intuitively, it's a technology used to sequence or read parts of the DNA of people. And from our perspective, it's also sort of the best of two different worlds. One is somewhat affordable, and the other one is it's really, really all encompassing almost. It sequences a lot of DNA. Whole exome sequencing covers many, many more genes than even the biggest gene panels. Some of you guys might have had gene panel testing done in the past, but whole exome sequencing covers less DNA than whole genome sequencing. Whole exome sequencing covers the DNA that codes for proteins, which is about 2% of your entire DNA. And whole genome sequencing does the 100%, so all the DNA. The reason why we decided to, for now, do all of our testing based on whole exome sequencing is that whole exome sequencing covers roughly 85% of all mutations that we know cause disease. So it's a pretty effective shot to get at a really big percentage of all the potential results we could be returning to patients right now.
Will you all ever expand to do whole genome sequencing or no?
Yeah, so we have our entire platform is set up for whole genome sequencing. So in theory, we could just turn it on right now. With the sponsor testing program we are doing right now, we have the option for people where we don't get a result with whole exome sequencing to potentially later down the line expand to whole genome sequencing and see if we can find results for them that the whole exome sequencing couldn't uncover.
You mentioned the sponsor testing program for mitochondrial disease. What is mitochondrial disease? What are the benefits of the program?
So mitochondrial disease, I think somewhat intuitively, it is a disease of the mitochondria. And the mitochondria are a specific compartment in your cells. And by and large, what they do is give your body energy. To me, the most intuitive way to understand mitochondrial diseases is imagine what would happen to the body if you didn't have energy. There's, something like 1,500 genes we currently know that cause mitochondrial diseases, which means there's probably 1,500 conditions at least. They, by and large, exist on a spectrum. So there are, very mild forms of mitochondrial disease where people just quite literally feel fatigue to some extent, maybe some like slight muscle weakness, and potentially have other issues that you would associate with what's it like to have less energy. And then on the most severe side of the spectrum, people have incredibly severe chronic fatigue. Children often die young. They might have severe trouble breathing, seizures. They might not be able to walk or might lose their ability to walk. Often there's a deterioration component over time that comes with mitochondrial disease. I'd say individually it really depends on the condition. Some patients with mitochondrial diseases as part of their condition have experienced stroke, severe heart disease. One symptom that people often report is brain fog. Dysautonomia is part of the spectrum. As you can tell, because the mitochondria are present in every single cell in your body, almost every single system in your body can be affected. The good news is there is an increasing number of drug developers trying to develop treatments for mitochondrial diseases. So where, a few years ago, there wasn't really much going on in the way of treatment development for mitochondrial disease, there's now more and more.
Which patients are likely to qualify? If they do qualify, will they receive follow-up care?
So the way it works is people can just visit our landing page at mito.probablygenetic.com. There's a symptom quiz on it that they can decide to complete, where they submit some symptomatic information to us. And then based on the symptomatic data people submit to us, we have an algorithm in the background that reviews every single submission and decides if that particular person qualifies for the sponsor testing program. People that eventually become part of the sponsor testing program get a completely free whole exome sequencing test, including a physician review that happens online in the background, as well as a genetic counseling session, which you did a review of in a previous video of yours, where the genetic counselor explains to them exactly what the results mean. And then they also get a write-up of what the genetic counselor told them. Anybody who participates in the program gets to take part in one of those genetic counselor sessions. We currently don't have anything in place to provide follow-on care to people, unfortunately. We are working on expanding our information package so that people who get the result report in the end can see here are other resources you can go to. We know that specifically wait lists to see the few mitochondrial disease experts in the country are extraordinarily long. So we know that this is a problem, but we currently, we sort of have to solve one problem at a time. And the first problem was, making a testing service like this accessible to people. The second problem was making it free to anyone. And then eventually, I think we'll hopefully get to a place where we can start thinking about follow-on care as well, but we're currently not providing that because the drug developers working on mitochondrial diseases are actively running trials. And so one thing that we do is if somebody gets tested positive for a trial that we know about, we can send them an email and let them know, if you wanted to, here is an offering that might make sense for you. So it's not quite follow-on care, but it's better than nothing, I'd say.
For the patients in the program, will the genetic sequencing screen for other conditions aside from just mitochondrial disease?
Yeah, so we run the exact same tests for our mitochondrial disease program that we run for everything else, which is a full-blown whole exome sequencing test. And the way that the analysis works is we look for literally any mutation that could cause the symptoms that the patient has. For example, there's a number of muscular dystrophies that look like mitochondrial diseases, but they're not mitochondrial diseases. If we found somebody like that and would be able to return a muscular dystrophy result, we would absolutely tell them. So we do not just limit the analysis to genes causing mitochondrial disease.
That was a big question of mine because I was in a study once and they said that if they had found something other than what they were looking for, that they couldn't tell me.
Right. Okay. I think I should expand on my explanation here. So it's good that you're following up on this. There's different ways to think about results in genetics. And so there are primary findings and then secondary findings. And some people also differentiate between secondary and incidental findings. In our case, we only return primary findings. So the way we define primary findings is any finding that explains the symptoms of the patient that we were looking for in the analysis. And when people get tested through us, they have to complete this pretty extensive intake questionnaire where they tell us their medical history, any symptoms, and anything else related to the disease. We then try to analyze their genome to see if we can find any explanation of those symptoms. Was that Teddy in the background?
Teddy, yes.
So cute. He wants to be part of the interview.
You did.
Yes. That's very sweet. Right. So that's primary findings, anything that explains the patient's symptoms. Now, secondary findings would be if we are analyzing your data to figure out what's causing a mitochondrial disease, but the patient also had a disease-causing breast cancer variant. We currently would not return the breast cancer result. So we do not return secondary findings, but people who come to us right now for genetic testing come with a specific disease concern, and we run the test for that disease concern.
Will you have other sponsored testing programs in the future?
Yeah, we're actually working on launching additional ones now. There's a range of conditions where I think this would make sense. The pressure there really is on us because we need to sign on additional sponsors who can fund more testing programs for people. But the plan is definitely to launch more disease programs.
A patient takes a survey and they are not eligible for the mitochondrial disease program, but they are eligible for one of the other programs that pop up in the future. Will their information be saved so that they can be contacted at a later date?
Yeah, absolutely. As I mentioned in the beginning, our mission is to diagnose 200 million people. So the more people we have that already submitted information to us, the more likely it is we get closer to our target. Even if you don't qualify right now, there's a number of ways in which you could get testing in the future. One is we might expand the number of tests that are available for existing programs, such as mitochondrial disease. And then another one is as we tag on more sponsored testing programs, there might be programs where your phenotype might also be suggestive of that condition. For example, we might launch, we don't have this in the works right now, but we might launch a muscular dystrophy program, right? And some people that are currently submitting to the Mito program, I can already tell you by their phenotype, look like they might have a muscular dystrophy as well. A lot of people ask us, what's the catch if I like, why am I getting a free test here? No financial catch. We're never going to get in touch with anyone and say, by the way, I told you back then this was free, but here's a bill. You're never going to pay anything. There's two things we do with the data. The first one is for people completing the symptom checker, we generate insights from aggregate data on that because drug developers have questions about those patient populations. If you do qualify for a free test and you were to get a positive test result at the end, we let the sponsoring company know who the treating physician is that people indicated in the intake questionnaire. So we never reveal any individual level data. We would never give anyone your contact information, genetic data, or any of that. But we might tell them this one endocrinologist in this town has a patient that tested positive for this condition. And the reason for that is when clinical trials become available, the people running the clinical trial could then go to that physician and say, we think you have a patient that might be a match for this trial. If you think that patient would be interested in that, can you pass along this information to them? So the physicians remain the gatekeepers for the patients, but it gives us a mechanism to give the right physicians more information that might actually be helpful for the patients. But the underlying most important thing is we never pass on any identifiable information to third parties or anything like that.
Why use probably genetic over whole exome sequencing performed at a geneticist's office?
Our goal is not to replace geneticists at all. We think they fulfill a different requirement from what we do, and they're like 100% necessary. We want to do a few things, and the most important one is make testing more accessible to patients, because as anybody in the chronic illness community knows, waitlists for geneticists are insanely long. If you're lucky, you're waiting 6 months. If you are out of luck, you might wait years. And we think this is a good way to fast track the process and get people access to testing. And I'd say the biggest argument probably is the testing is completely free. So you don't have to wait to go see anyone, and you don't have to pay anything. All you got to do is go to mito.probablygenetic.com, take the quiz, and then it takes a few days for your request to be reviewed. And if you get a free test, you get a kit shipped, and a few weeks later, you have an answer. I guess I would tell people that if you're already seeing a geneticist and like they're organizing testing for you, fantastic, like follow that route, because we do not provide you with a geneticist who can help you figure out the follow-on care. You're in fantastic hands. But if you're either on a wait list and it's taking ages for you to even get in, or you're worried to leave your house right now and like be in a physician's office because of the pandemic, or like you, yeah, tons of people are immunocompromised, right? You don't necessarily want to be out there right now. Or if you just can't afford to see a geneticist or the testing bill, then I think this is a good option for you.
And for those who are interested, I will put the link to the survey for the study down in the description below. I will also put Lucas's contact information. You guys stay tuned for the next video, which will include my personal experience with genetic testing and mitochondrial disease testing specifically, and then you'll hear a little bit more from Lukas too.